Now let's take a look at the third problem here. Actually, we did something similar back in earlier chapter. So now we are gonna look at it from another angle. So first of all, if you plug in infinity, you see that this is gonna be infinity minus the square root of infinity squared, basically infinity minus infinity, right? So it is indeterminate form. Now, if we want to begin, so this is the trick that we're going to use. So limit x approaches infinity. Uh, we want to convert it into 0 times infinity type, okay? So therefore, I'm going to say x minus factorial x squared here inside the square root. So we're left with 1 plus 4 over x. So if you factor out the x squared, that's what you have inside the square root. Now, after the square root, you see that square root of x squared will be equal to x. So therefore, you see a common factor, x. I'm going to factor out my common factor. So x approaches infinity. So x is a common factor. So once you factor this out, you're left with 1, right? For this part. So you're left with 1 minus. Imagine that there's another x. This square root of x squared will be x. So therefore, when you factor out that guy, you're left with square root of 1 plus 4 over x. Okay, let's check. When you plug infinity, this guy will be infinity. This is 1 plus 4 over infinity is 0. So therefore, this is going to be 1. Square root of 1 is 1. 1 minus 1 is 0. So infinity times 0 type. Now, if you have infinity times 0, the best way is to convert it into one of the two forms, infinity over infinity or 0 over 0. Here's the reason that I choose to do the way that I'm using. So I see that 4 over x. 4 over x. In other words, I see 1 over x in here. So therefore, I would like to keep this on top and then rewrite x as 1 over the 1 over x. So basically, I'll just x becomes 1 over 1 over x. So I place that back in the denominator. So do you see that now? You see a 1 over x right here, and then you also see 1 over x here, which is nice. They match. When you find the derivative, they can be cancelled. They can be cancelled. That's why I choose to do that. Now let's check the form. When you plug infinity, this is going to be 0. This is 1 over infinity is 0. So it's 0 over 0 type. Actually, at this point in time, you could certainly go ahead do the derivative, and the book actually suggests the change of variable. Sometimes I don't feel that that's really necessary, so usually I just go ahead find the derivative. So this is what I do. So the limit x approaches infinity. Okay, let's take a look at the bottom. What's the derivative of the bottom? I'm gonna just say derivative of the bottom, okay? Derivative of the bottom, which is derivative of 1 over x, okay? And the top, derivative of 1 is going to be 0. So therefore, I just need to focus on the derivative of this square root. I need to use chain rule, call the inside part as my u. Then this is what I would do. So negative, think of this square root as power 1/2. So therefore, use power rule 1/2 times the u, which is this guy, right? 4 over x raised to power 1/2 minus 1, which is negative 1/2, times, keep in mind, you need to use chain rule, so times the derivative of inner. The derivative of inner for this piece, derivative of 1 is 0 because it's constant. And derivative of 4 over x is the same as 4 times derivative of 1 over x, right? Derivative of 1 over x. Where's the 4 from? I kind of pulled it out, the constant. Do you see that these two are identical and you can actually cancel? When I look at the previous step, I kind of foresee that this will be canceled. That's why I did not really find the derivative of this guy, but this can be done. Now after that, I'll try to plug in x infinity into x. So 4 over infinity will be 0, right? This will be 0. So 1 plus 0, which is 1, 1 raised to power any power is going to be 1. So therefore, this piece, this whole piece will be just 1 after you plug in infinity in x. This is going to be 1. And then negative 1/2 times 4, you get negative 2, right? So negative 2. So this is my final answer. This is my final answer. How do you check that whether you are correct or not? My suggestion is, hey, how about you graph this function and then take a look at the end behavior. When x is approaching infinity, you should see a horizontal asymptote x equals negative 2. If you see that, you are correct. So that's how we use L'Hopital's rule. This is where the L'Hopital's rule comes in, right? L'Hopital's rule comes in. Now, if you can recall, actually, this is a good moment for you to kind of review previous in chapter, I believe chapter 2, we actually have this type of problem. And back in that time, the suggestion was multiply the top and the bottom by the reciprocal of this expression and then go from there. So I'm not going to demonstrate this in my video, but please check my notes. I will provide this second method in my notes.